let's look now at the pattern. We're going to look at the pattern of the function, and it's the area under the curve, which is this, has this elaborate formula in terms of, so this is just the area under the curve. Between 0 and b. And we have x squared, which turned out to be b cubed over 3. And we have x, which turned out to be, well, let me write them over just a bit more to give myself some room. X, which turns out to be b squared over 2. And then we have 1, which turned out to be b. So this, I claim, is suggestive. If you can figure out the pattern, one way of making it a little clearer is to see that x is x to the first power, and 1 is x to the 0 power. So this is the case 0, 1, and 2. And b is b to the 1 divided by 1. So if you want to guess what happens when f of x is x cubed, well, if it's 0, you do b to the 1 over 1. If it's 1, you do b to the 2 over 2. If it's 2, you do b to the 3 over 3. So it's reasonable to guess that this should be b to the 4 divided by 4. Right? That's a reasonable guess, I would say. Right? Now, the strange thing is that in history, Archimedes figured out the area under a parabola. So that was a long time ago. It was after the pyramids, and he used actually a much more complicated method than I just described here. And his method, which is just fantastically amazing, was so brilliant that it may have set back mathematics by 2,000 years. Because people were it was so difficult that people couldn't see this pattern and couldn't see that actually these kinds of calculations are easy, so they couldn't get to the cubic. And even when they got to the cubic, they were struggling with everything else. And it wasn't until calculus fit everything together that people were able to make serious progress on calculating these areas, even though he was the expert on calculating areas and volumes for his time. So this is really a great thing that we now can have easy methods of doing it. And the main thing that I want to tell you is that we will not have to labor to build pyramids to calculate all of these quantities. We will have a way faster way of doing it. This is the slow, laborious way. And we will be able to do it so easily that it will happen as fast as you differentiate.